For those of you who decide not to complete or don't have time to do any of the optional sections in this class, this chapter is really the last bit of new material that you're going to have in this course. All of the units after this that are going to be on the final are really just applications of the principles that we cover in this chapter and from all the units before. And so the first thing that we're going to add, we've already basically talked about already, but we're just going to kind of expand on it a little bit, are the equations of motion. So remember that we can be given position as some function of time. And then we can take a derivative with respect to time of position, and that will give us a velocity, where the velocity is dr of t dt. And then we can take another derivative with respect to time, and we get an acceleration, which is the first derivative of velocity, which is also the same thing as the second derivative of position. Right, but then we can also go back the other way. We can take an integral, and so we see that velocity is the integral of a dt, and then position is the integral of velocity. So in this way, we can always go from a position to a velocity to an acceleration, or the other way around. We can always, if given any one of the three, we can find the other up to some constant, where we just recall that, for example, let's say I'm given an acceleration in a gravitational field where the acceleration is minus g y hat, then I can say that the velocity v is the integral of a dt, which is minus gt y hat plus v0, where v0 is some constant vector. And I note that it's a vector. It doesn't necessarily have to be just in the y hat direction, right? I could have had something like v0 is equal to 5 meters per second in the x direction and no y or z coordinates, and because if I still, when I take the derivative of that, I see that this is 0. So taking a derivative of this term would still give us the acceleration minus gy hat. So that's the only point that I'll really make on this. Other than that, this is nothing new that we haven't talked about already.